Welcome to the video on bond strength and length. So we will talk about two things in this short video. One is on the hybridization of the carbons that are attached. In other words, we will talk about the difference between a single bond, a double bond, and a triple bond in terms of strength and length of those bonds. And then we will talk about heteroatoms, bonds that carbon has to other atoms on the periodic table. And so we'll start with the hybridization. So if we look at an sp3 hybridized carbon that's bonded to an sp3 hybridized carbon, we have this sigma bond, this single bond, and the bond distance is 1.4 angstroms. If we move on to the sp2 hybridized carbon, bonded to an sp2 hybridized carbon, we have a carbon-carbon double bond, and that distance is 1.34 angstroms. And if we keep going and move into the sp-sp bond, that is going to be a carbon-carbon triple bond, and that distance is 1.2 angstroms. So you can see as you increase the number of electrons in the bonds, right? So we have single, double, triple. So here there is 2 electrons, here there is 4 electrons, and here there are 6 electrons. So as we increase the number of electrons in the bond, it makes it stronger and shorter. The other thing that we can think of is when we talked about an sp3 hybridized orbital, that orbital was a little bit longer than an sp2 hybridized orbital, which is a little bit longer than an sp hybridized orbital. So it makes sense based on how we picture the hybridized orbitals as well. So the shortest is 1.2 angstrom, is also the strongest. And it turns out too, because the sp3 is 24% S, the sp2 is 33% S, and the sp is 50% S. If we think about that, we might also say that the trend is as you increase the S character, you are making shorter bonds and stronger bonds. So if we now move on to talking about carbon bonded to other things, we'd start with the carbon-hydrogen bond and the carbon-carbon bond. The carbon-hydrogen bond is 1.09 angstroms, and the carbon-carbon bond is 1.54 angstroms. So we see that the CH bond is a little bit shorter, and if you look at the energy to break it, it's a little bit stronger. And remember, the definition of an angstrom is 1.09 times 10 to the negative 10th meters. The CH bond is a little bit shorter and a little bit stronger than the CC bond. And now if we compare carbon bonded to many other heteroatoms and look at the energies that are required to break those bonds, the CH bond, right, is a little stronger than the CC bond. And if we look here, as you move down the periodic table, we are decreasing in strength. So if we are decreasing in strength, we are increasing in distance. So the CI bond is going to be the longest, and the CF bond is going to be the shortest. And that is because the CF bond is the hardest to break, so that's the shortest. CI bond is the easiest to break, so that's going to be the longest. This trend also has to do with the size of the atom. Fluorine is much smaller, and so it can fit tighter next to the carbon, whereas iodine is much larger, and so it's farther away, and so that makes the bond length bigger. So as you go down the periodic table, the bond strength decreases. And as you go down the periodic table, the bond length increases. And if we go across the periodic table, CC, CN, CO, and CF, so we're moving right across the periodic table, we see that there's no necessary defined trend. So we're going to have to kind of just pay attention to each of those individually. But a quick recall, as we have a CC single bond is definitely easier to break than a CC double bond, than a CC triple bond. Our review for here is that for hybridized atoms, the more S character makes it stronger and shorter. So why don't you try? Which do you think is stronger, a pi bond by itself or a sigma bond by itself? You might want to pause the video. So sigma bonds are definitely stronger because it requires almost twice the amount of energy to break than a single pi bond. Now, we're not talking about a double bond. We're talking about just the pi bond piece. Remember, the sigma bond is front end overlap, and the pi bond is this kind of sideways overlap. So a sigma bond by itself is stronger than a pi bond by itself. Of course, a sigma bond is weaker than a double bond, is weaker than a triple bond, but that is not what this question is asking. Which should be longer, an sp3 sigma bond overlap or an sp-sp sigma bond overlap. And we did actually just talk about this. Remember, if we think about the shape, the sp3 hybridized orbitals are a little bit longer than we have an sp hybridized orbital. The answer is sp3 bond lengths are longer than sp2, then sp. So if you have a longer bond length, it makes it a weaker bond. Okay, there you have it, bond length and bond strength.